Hello and welcome to 6.5 Notes. So in section 6.4 we learned that we can use congruent corresponding angles to show that two triangles are similar. So in addition to that, we can also use proportional corresponding side lengths to show similarity as well. So that's the side-side-side similarity theorem. And it states that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So what that means is if you have, for example, side AB, which is going to be proportional to side RS, and you have BC proportional to ST, and if you have CA, this side here, proportional to TR. In other words, when you divide this by this by this, if you get the same number each time, like 3 over 4 or 4 over 3 or 4 over 9, every time, the same ratio every time, then triangle ABC is said to be similar to triangle RST. Okay, so it's another another theorem that we have to show similarity. Okay, let's try to illustrate this theorem with a problem. And the problem is, which of the three triangles are similar? And then once we have found which two of the three triangles are similar to each other, then we're going to write a similarity statement. So let's start off with trying to show if these two triangles are similar. Okay, and I'm first going to notice that ML is my shortest side on this triangle. So ML must correspond with RS on this triangle because 24 is my shortest side on this triangle. And so the way I'll be traveling around the triangles is short, long, middle, and that's going to correspond with short, long, middle. So I'm going to be trying to find out if triangle MLN is similar to triangle RST. And if those two triangles were similar, then the corresponding side lengths would be proportional, right? They'd be in the same ratios. So you would have this would be true if these two triangles were similar. So I'd be comparing the short side of this triangle with the short side of that triangle. That's where you get the 20 over 24. And then we have the middle value of this triangle compared to the middle value of this triangle, and that's where you get the 24 over 30. And then we have the longest value of this triangle and the longest side here, which is 33, and that's where you get that. So if those ratios are equal to each other, then we have similar triangles. If they are not, then they are not similar triangles. And so when you reduce these into lowest terms, you have 20 over 24, which equals 5/6, 24 over 30, which is 4/5, and 26 over 33, which is in lowest terms 26 over 33. And as you can see, these values are not equal to each other, so no, those triangles are not similar. Okay. So let's try the same thing with triangle RST and triangle ZYX. And so we have, is 24 over 30 equal to 30 over 36, which is equal to 33 over 39. And remember, these are, of course, the corresponding side lengths, and we're trying to find out if they're proportional, if they're in the same ratio. And when we bring them down into lowest terms, we could see that they are not proportional, and so, again, no, these two triangles are not similar. So let's try the last pair and see if that will work. Is triangle MLN similar to triangle ZYX? If they were similar, then their corresponding side lengths would be proportional. So I would have the short side length and this short side length, where is it, which would be that one, 30, and that's where you get the 20 over 30. And then the middle value would be 24, and this middle value is 36. That's where you get that from. And then the largest or longest leg is 26 over 39. That's where you get that. And so if these are in the same ratio, if these are proportional, then the triangles are similar. And 20 over 30 reduces to 2/3. 24 over 36 also reduces to 2/3, and 26 over 39 reduces to 2/3. So yes, by the side similarity theorem, these two triangles are similar. And then part of our problem was to create a similarity statement. So that would be triangle ZYX. So in this next problem, we have that the shortest side of a triangle similar to triangle RST is 12 units long, and find the other side lengths of this new triangle. So first off, I'd want to notice that it says that the shortest side is 12 units long. Well, then that must be corresponding to 24, because 24 is my shortest side of triangle RST. So that's what leads us to this proportion. Okay, this is giving us some information regarding, in a sense, the scale factor between this new triangle and triangle RST. It's short compared to short, which is 12 compared to 24. So we can see that the ratio is 12 to 24, or 1 over 2, right? 1 to 2, 1/2. So some of you might be clever enough to know that, well, then the middle value of this triangle must be half of 30, which is 15, and half the other value will be half of 33, which is 16.5. But if you're not getting that, I'll kind of explain that in more detail, and hopefully you'll understand it that way. So again, we have that this is the ratio between all of the corresponding side lengths, right? 12 to 24, or 1 to 2. So we can use that ratio, 12 over 24, and set that equal to x over 30. So I'm just going to use these two ratios for now. And then we can solve this by cross-multiplying and get that 24x is equal to 12 times 30. And then just performing the mathematics, we get x equals 15. And then to find out what y is, we can basically just use this and that. Okay, so we can set 12 over 24 is equal to y over 33, and that's how we get that proportion. And then again, you can solve that by cross-multiplying these two. Okay, and you get 24y is equal to 12 times 33, or y is equal to 16.5. So that's how you can use the side similarity theorem to find missing side lengths. Okay, and then new concept here is the side angle side similarity theorem, which states that if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So for example, we have side ZX is corresponding to side PM, and we have side XY corresponding to side MN, and those are going to be proportional. And we also have that the angle, the included angle, the angle in between those two sides are congruent to each other. So if all those things are true, then by SAS, side angle side, SAS, okay, by side angle side similarity theorem, we can say that triangle XYZ is similar to triangle MNP. And so we have 3 ways to show triangle similarity. And you will be responsible for knowing these 3 ways, so at some point you should write all these down and be able to use them to show triangle similarity. Okay?
So if you like, you can pause this presentation now and copy these down. You will be responsible for understanding how to use these to show triangle similarity. Okay, but for the sake of this presentation, I'm going to continue. So we have 2 more problems, and they both have the same set of instructions, which is to explain how to show that the indicated triangles are similar. So we have these 2 triangles, and it is our job to show that triangle SRT is similar to triangle PNQ. So remember, like I said, we've covered quite a bit in the past in other chapters, and even continuing with this chapter. we need to show that these two triangles are similar. And remember, the order in which you travel around the figure and also the order in which you travel around the letters is crucial. So SR are the first two pair of letters, and PN are the first two pair of letters in this triangle. So SR must be corresponding with PN. Okay, so we're going to have 24 divided by 18. And then we have RT and NQ, because we have RT here, the last two. I'm going to make this larger here. RT and NQ. And so those must be corresponding as well. And so we have that SR divided by PN is equal to RT divided by NQ, right? These are the corresponding side lengths. So let's look into that. Is 24 divided by 18 equal to 28 divided by 21? And the answer is yes. They are both 4/3. And angle R is congruent to angle N, right? They were both 90 degrees. And so we have that the triangles are similar by the SAS similarity theorem. Okay, now we have just one more problem to go. It's the same instructions to explain how to show that the indicated triangles are similar. And now it's our task to show that triangle XZW is similar to triangle YZX. And remember, the order in which you travel around the letters is crucial, so I've just recopied these here for your convenience.
And we have that triangle angle WZX, angle WZX, which would be this angle, is congruent with angle XZY, correct? Those two angles are congruent by the linear pair postulate. So we have these two angles, and we have corresponding sides. So we have WZ and XZ are corresponding, and XZ and YZ are corresponding, and WX and XY are corresponding as well. So let's see if these corresponding sides are proportional. In other words, let's see if 16 divided by 12 rather. Let's see if 16 divided by 12 is equal to 12 divided by 9, which is equal to 20 divided by 15. And if those are all the same ratio, then we can use the side similarity theorem. And yes, they are all equal to 4/3. So we have a choice. We can show that the triangles are similar by either side or the side angle side similarity theorem. If we want to use this information regarding the proportional and corresponding side lengths, or rather that the corresponding side lengths are in fact proportional, then we can use side. Or we can also use the fact that the included angle in between the two sides, right, these two angles, are also congruent, right, they're both 90 degrees, then we can go ahead and use side angle side. So we have a choice. We can show that the triangles are similar by either one of the two methods, either the side similarity theorem or the side angle side similarity theorem. So that's the end of the lecture, and always feel welcome to ask me any questions or concerns you might have, and I would love to help you. It would be my pleasure to help you or set up an appointment to meet with you for a little private tutoring session. So again, that's the end of the notes, and until later, bye-bye.